In this lesson, we will look at a couple examples illustrating how to solve linear inequalities. Here's the first example. 2 times the quantity x minus 3 is greater than 5x minus 1. Now, to solve a linear inequality, we use the same processes to solve a linear equation. Namely, we simplify any expressions, we combine like terms, and in the end we try and isolate the variable. So in this case, our first step needs to be simplifying the left side. So let's distribute the 2 through the parentheses. That will give us 2x minus 6 is greater than 5x minus 1. Now that we've simplified both sides, we need to move all the x terms to one side of the inequality, and any term that doesn't have an x, we need to move to the other side. Now, I typically just like to have the x's on the left, but it doesn't really matter. Let's go ahead and move all the x terms to the left, and then we'll move the non-x terms to the right. So we'll need to subtract 5x from both sides. So that gives me a negative 3x minus 6 is greater than a negative 1. And then we can move the negative 6 over, so we need to add 6 to both sides. And that leaves me with a negative 3x is greater than 5. And the last thing that we need to do is to get the x by itself, we need to divide both sides of the inequality by negative 3. Now here's the one difference when solving an inequality. Whenever you multiply or divide both sides of the inequality by a negative number, we have to flip the inequality symbol. So since I just divided both sides of this inequality by negative 3, I need to flip the inequality from a greater than to a less than. So this is the answer for our inequality. And if we wrote it using interval notation, we would have an open parentheses, negative infinity, comma, to negative 5/3. And since it's strictly less than, we don't have the equal to. That means we're not going to include the negative 5/3. So that would also be a parentheses. Now let's look at a second example. Now in this example, it's a little different because we see we actually have 2 inequality symbols. Now the middle part here is still just a linear expression, so we can solve it basically the same way we did. And when we do that, there's kind of 2 ways we could do it. One way would be to ignore the right inequality first, so to think of just the inequality of negative 3 less than or equal to 1/5 x plus 2 and solve that separately, and then go back and do the whole thing again using the less than 7 inequality. Or we could solve the entire inequality together. We just, whatever you do to the middle, again we try and isolate the x, so whatever we do to the middle, you do to both sides. And that's the easiest way to do it, so that's what we'll try doing here. So to get the x by itself, I need to subtract 2 from both sides. But now instead of actually subtracting it from both sides, you need to subtract it from all 3 sides. So on the left side, we have a negative 3 minus 2, so that's a negative 5. And that's less than or equal. It was 1/5 x plus 2, now it's just 1/5 x. And then we have strictly less than, and so now we have 7 minus 2 on the right side, which also gives us a 5. Now to get rid of the 1/5, so we isolate the x, all we need to do is multiply all 3 parts of the inequality by 5. So if we multiply over here by 5, we multiply the middle term by 5 and the right side by 5, all 3 parts. On the left side we have a negative 25 will be less than or equal, the 5 and the 1/5 cancel, so we're just left with an x, and that would be less than 5 times 5, which is 25. So the answer in inequality notation would be negative 25 is less than or equal to x, which is less than 25. If we wanted to write this in interval notation, we would start at negative 25 and we'd go to positive 25. And if we look at the endpoints, since the negative 25 is potentially equal to the x, we show that it's included by using a square bracket. And since the positive 25 is strictly greater than the x, we show that by using a parentheses.